Hello students, this is lesson U3A01b. In this lesson, we are going to be applying theorems of isosceles and equilateral triangles to solve problems. So in this lesson, we're going to be talking about the angle bisector of an equilateral of an isosceles triangle. So the theorem here actually states that if a line or a line segment bisects the vertex angle of an isosceles triangle, which in this case, that's exactly what is happening right now. This is the a line, and it's bisecting the given angle there. If that were to happen, that line that I'm highlighting in blue will become the perpendicular bisector of this base. The base is going to be bisected into two equal parts, and also that angle bisector will form a 90 degrees with the base. All right, now that we have this understanding, and it should make sense that this is what's happening here. We have an isosceles triangle, this line that goes right down the vertex. Okay, it breaks up the two angle in half. Visually, it should make sense that this side here is going to be the same as that side there. And visually, if you were to use your eyeballs, right, it would make sense that the angle bisector is in fact perpendicular to the base. Alright, so now with that understanding, let's try to solve some problems. Here we're trying to find the side length of PR and the angle RSQ. So how are we going to do this? So I know that this is an angle bisector, right? This line QS is an angle bisector because of this angle here that it's indicating is the same. Okay. I also recognize that PS and RS are the same length, so therefore PRS is an isosceles triangle. Therefore, this must be 31, and this must be 90 degrees. The task here is to find a side length of PR. So if this is the case, then PQ must also be 4. So therefore, PR must equal to 8. And we need to find out what angle RSQ is, right? So if the two angles there are 31 apiece, RSQ being this angle here, this must be 180 minus 31 minus 31, 180 minus 62. This is 118. Alright, so I encourage you to pause the video and try to figure this problem out on your own. Here we need to find out what is angle BDA if angle CBD, which is this entire angle, is 130. What will be the angle of BDA? What's this guy right here? Alright, so let's try to figure this out. So I know that this angle, that triangle ABC is equilateral because all three sides are the same length. Therefore, these must be 60 apiece, 60, 60, 60. If angle CBD is 130 degrees, that leaves me with this angle. Well, if it's 130, let's do 130 minus 60. This must equal to 70. And if this angle is 70 degrees and angle ABD is isosceles, because I recognize that AB is the same length as DB, then these two angles must be the same measure. It's an isosceles triangle. So if this angle here is 70 degrees, okay, and I don't know what angle D or angle A is, but I know that they're the same, so I know that 70 plus X will equal to 180. Therefore, 70 plus 2X is equal to 180. Therefore, 2x is equal to 110. X must equal to 55 apiece. All right. Let's take a look at another question here. And again, I encourage you to pause the video and to try this out on your own. Hopefully by now everyone has gotten a chance to look at this. We need to solve for x. So recognizing immediately that this is an isosceles, that we have two different triangles here and two different isosceles triangles for that matter. So I know that this side length here is 2x plus 5 And I know that this side length over here is 4x plus 3, but I also recognize that these two base angles are the same. So if that's the case, then this angle, or not angle, that side must be 4x plus 3. Okay, so if that is 4x plus 3, okay, and I know that these two sides must be the same length because this base angle and this base angle are the same. So again, I'm dealing with another isosceles triangle, so therefore I can say 4x plus 3 will equal to 5x plus 1. What will x equal to? Subtract 4x and subtract 1. I will end up with 2 is equal to x. And then all the various sides we can solve for as well. The question didn't ask for it, but I went and solved for it anyway. That's it.